Yeah, so you should have just received a email saying, hey, here's a practice exam. And let me just plug this in now. Okay. Trying to use that mouse. All right. Give me a second. I realized the projector wasn't on. No, that's too tall. But this is too short. All right. So we've got, as I've said, I've got a practice exam. Sorry, I've sent out a practice exam. I always try to give you a week's worth of note. Exam is on April 2nd. Review will be on April 1st. So I'll be in lab. My plan today is that we're going to take a very brief look at the exam, but I'm not going to go over the questions in terms of here's how you solve them or any of that. But then after we go over after I kind of just introduce it to you, then I will go over the cheater's hangman. Okay. So practice exam is again a very good equivalent here. Let's just start off with how much coding you have. You will be having you have 2 questions worth of coding for trees and 1 question worth of coding for maps. So I think about 30. What is it? I'd have to double check. Maybe 35-ish points worth of the exam is coding. So less than last exam. There will be two questions on the 2 questions I'll be asking on the practice exam are going to be interrelated. In other words, you do part A, and then you can use part A to solve part B. However, if you're unable to solve part A for some reason, then for part B, we're just going to assume that part A works, right? So that it doesn't impact your grade necessarily. It's technically it's all one problem, but I split it up into 2 to make the thinking about it a bit easier. Then the other question will be a similar question that I'll be asking to our students in 1051 for their exam, although they're going to be doing it for dictionaries. Something like this, write a method that returns what characters occur in a string and how many times each occurs, right? So that might be, on the exam, it might be, here's a string, how many times do words occur? Does each word occur in the string? Ignore punctuation, right? Or it might be a list of words, or it might be something else, right? It's just a matter of kind of iterating over it. So those are your coding questions. So let's go ahead and just kind of give you a focus though on these. Again, you'll notice that the exam is much longer than I normally. The practice exam is normally longer because I also fill it with extra practice questions. So here, this question is also a kind of question there will be questions like this on the first page of the exam. I'm very fond of asking questions like this on the final exam too, which is, hey, here's a bunch of scenarios. Tell me which data structure we should use for this scenario. It becomes even better the more data structures we know. This is not uncommon for data structures exams, because part of why we learn data structures is sometimes just knowing the right data structure to use solves. Sorry, give me a second. It solves the problem for us automatically, right? We just kind of know, and it works. All right, vocabulary questions. So if you've taken the tree quizzes, and hopefully you have at this point, right? The kind of stuff that you'll be answering on the exam will be very familiar. Will be very similar to the questions you had on the on the quiz. Actually, I don't even know if they might be identical to the ones on the quiz. I have not bothered checking, and if they are, more power to you, I guess. But just kind of remembering our vocabulary. And then basically there's going to be plenty of drawing on the exam. So unfortunately, I'm not asking for anything like super, Da Vinci quality, Picasso, maybe, with a nice bit of abstractism, but basically drawing our a different example and of different trees. And the reason I say use a different example is technically this would be the correct answer for all 3 problems. So that's why I say use a different example so you can actually practice. So draw the operations that would occur after inserting the following integers. And so basically here I'm lazy and I basically you'll get a question exactly like this one, but basically you have to do like 42 and then, okay, 10 and then 50. I find it's easier to do numbers rather than letters for these, so you'll be getting numbers because then you don't have to go A, B, C, D, E, F, G, you know. So use your previous answer, draw what happens when you remove the following. In this case, here I'm being lazy and using your answer here, making you use your answer, but on the exam I'll actually give you a fresh tree that you know will be correct. And then, yeah, if you show me the final answer, great, you'll get full credit. But you might mess up, so be sure to draw your steps, especially for the delete problem. Because if you can give me like, okay, we went to this, to this, to this, to this, I can see if you messed up where it was and give you partial credit. Right, so definitions, heap question, I told you about this last week. You'll get questions about heap, how do you make a heap, right? We start at the top and then we go left to right across each layer, right? And then draw the heap after removing an element twice. Huffman coding, right? That's, I go over that in the videos. It's quite the extensive thing to devote time to class for, or additional time in class, but simply put, you are making a priority queue, and then so that's where the heap comes in, and then you are building a Huffman tree based off of that with the, I believe it is the least, yes, the least goes first. So for instance, you would arrange them in order, X, L, P, A, E, and then what you would do is that you'd say, okay, let's take the 2 off, combine and put them as nodes for a new, combine them into a single node and then put that node with the combined weight back into the tree. Refer back to the videos, but it is one of those questions that is can be a bit tricky, but it's worthwhile to get. If you somehow, and of course, if you somehow get this part wrong, right? If you somehow get this part wrong and draw the wrong tree, but you use what you drew to do the encoding or decoding, I'm going to give you credit based off of what you drew if you correctly based it off what you drew. So first I'll obviously look for the correct answer, but if that's not the correct answer, I'll look, hey, does that answer correlate to the incorrect answer you had above? Oh, yes, it did. Okay, I'll give you credit for this. The recursive coding in this class, for this exam, is going to be on the tree problem 1 and tree problem 2. So this one, size tree, right? This is just this is going to be easier than what's on the actual exam. Good warm-up problem for you. This is going to be harder than, possibly, I think maybe slightly harder or equal to what's going to be on the exam. And this is definitely a bit trickier, I would think. The equals. Not necessarily, though, but equals is a good kind of practice, which basically says, hey, are these 2 trees equal? Do they have the same structure and content? Sorry, yesterday I thought I was sick. Turns out, no, just allergies, I think. So that kind of easy. And how do I know? Well, I took allergy medicine and I feel amazingly better, but still sneezy. But I don't feel like I'm dying anymore. So analysis questions will be at the end. You'll probably have one analysis question on trees and one analysis question on hash tables, things that require you to kind of brainstorm and kind of think outside the box. Okay. So that is that for the practice exam. It's, again, like I said, the students who study for this exam do very well on this exam. Okay, so if you're prepared for this exam, you'll do very well. If you don't prepare for it, you're not going to do well. But most of the students do prepare for this exam because you're all diligent students, and I'm always pleased with the scores for this exam. So let's go ahead and check out the whiteboard. Yes, you have a question.
Yeah, you said on source or at the end?
What?
You said on source or at the end?
Uh, no, I'll be going over I'll do the questions in class on April 1st. So that way you have the chance to run through the exam and kind of time and either just work through the problems at your own pace or time yourself depending on what your preferred method of studying is. Again, a lot of what I've done here is I've made twice as many questions as I needed and then kind of just divided them up among the exams. And so I don't have to make a separate practice exam every year. Sometimes I tweak the questions on my actual exam. So, all right, so let's talk about Hangman. The dictionary assignment is called Cheater's Hangman, and the way it works is that, or it's also known as Evil Hangman, and the way it works is that we've all played, most of us, have played Hangman. If you are from a country where basically you are using a non-alphabetic set of characters, such as Mandarin, then suddenly Hangman doesn't really make sense as a game for children, right? There's other word games such as I'm going to, I have to start my sentence with the syllable that we ended on, and then the next person has to do so. So kind of a chain of those kind of things. But for Hangman, it's let's just simply review the rules very briefly. I've got a hidden word here. Sorry, in normal Hangman, you've got a hidden word. Let's say I choose the word goat, right? G-O-A-T, that is my hidden word. But to you, you see this, and if you guess a letter that's in it, like T, so say you guess T, I'll reveal that letter so that you can see that it's there. And if you get it wrong, I start drawing. And then as you get more and more wrong, we draw a hanged man. It's amazingly how morbid some children's stuff is. So anyway, that's the idea behind Hangman. We just, it's a guess a certain number, guess the word correctly before you make the requisite number of incorrect guesses. But part of what Hangman relies on is the fact that basically that the person who chooses the hidden word, actually commits to a hidden word. If, on the other hand, you did not commit to the hidden word, suddenly you can make it so that basically the player loses all the time, or very close to it. So, for example, suppose we are in this scenario near the end of the game, and we have the following, and this is like we have one guess left, and we see this. And we've guessed R, S, T, L, sorry, not L, but N, F, U, right, enough that basically we've got one thing left. And so now I'm thinking of and so now you've got basically one guess left. In the version of Hangman we're going to be making for our computer, with the computer, it's going to work like this. If you tell me, oh, the word is goal, I'll say, oh, I'm so sorry, the word was goad, right? And if you told me goad, I'm going to say, I'm so sorry, the word was goal. I'm not going to say the word was goat, because we've already guessed a T, and that would be incompatible with our previous guesses, right? So part of it is that we need to make sure that whatever lies we tell are compatible with the guesses that the player have already made. Ugh, gross. Okay. Anyway, the way this works is that rather than playing Hangman, one game of Hangman, what we're going to do is we're going to play hundreds upon hundreds of games of Hangman simultaneously. We are going to pretend that every single word in the dictionary is one of the words we're playing with. So what do I mean by that? First off, let me go ahead and just simply say, let's go over here to the modules for a second. I want to make sure, I'm trying to remember, do I have to give you code, or did I already give you code for that? Okay, no, I did not give you code. Okay. Right, so you can work with another person on this, and you can kind of do it as a paired programming assignment. Okay. Jeez. So I go into more examples here. Sorry, I feel like I've got another sneeze coming, and that sucks. Okay, so what we're going to do is that we will go through, that we're playing a game of 4 letters in Hangman. What we're going to do is that we are going to then load up all the 4-letter words from our dictionary file. Okay? All the 4-letter words. And then what we're going to do is that we will, if the user makes a guess, such as E, what we're going to do is we're going to play through every single word as though that is the word that was chosen. Okay? So, for instance, if we look at able, for instance, then that would be the word able would, if we had chosen able, we would show them, because they guessed E, we'd show them blank, 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 E. Right? And so I'll just simply put this here, able, blank, 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 E, able. Words like ball, right? Blank, 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 ball. And then let's go with and then maybe a word like edge would show up like this, right? Edge. And another word that might show up like this is eels. Well, eels would show up like this, right? So what's important to note is that it's not just the number of letters, it's also the position of the letters that matter, okay? So we've got able going here, we've got ball going here, we've got edge going here, we've got eels going here. And words like goat and goal would all get added to this blank, 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 blank category. Why? Because they all have kind of the same, they all basically go to the game state. What we're essentially doing is that we're taking every single word in our dictionary and categorizing them on which future they would belong to, what future game state this would lead to if we chose this. So for instance, if we went with this game state, we'd basically be saying, here, we're going to go with all the words that end with the letter E. If we went with this game state, we're going to go with all the words that don't have any E's. If we went with this game state, it would be all the words that have E, blank, blank, E. And so let's see what the example I have is. So, yep, so let's look at this. We have maybe another one. Let's see. So echo might go over here. Echo. Right? So each time we find a different category, we make a new category for that. Right? Same with eggs. If we had eggs, that would end up in this category because the category for it does not exist. Make sense? So we're basically the term I use in the PDF or the original author was word families. We're breaking them up into families. But you can think of them, again, as different futures. Okay? Now, we do like to avoid committing to an answer as long as possible, but our hand gets forced whenever they make a guess. We have to basically say one of these futures is going to be the future we go down. Okay? And so what we'll do, now you can actually use any heuristic to decide which of these families you want to choose. Okay? But I suggest doing the largest word family, the one that has the most words in it. Why? Because that's simple, and it kind of says this gives me the most options to dodge an answer. So how would this play out in basically a demoing process? Well, I'm going to demo off of 8 guesses, okay, and I'll show you kind of how this example would work with 8 guesses, okay? Let's draw that a bit better. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what I'll do when I demo is I'll say, give me 8 letters. Tell you however many guesses, and I'll say, okay, first letter I'm going to guess A. And what it's going to do is it's going to go through and say, no, there are no A's in this. And it's not going to show me any answers, right? Because we're going with a word family that has no A's in it. This also means that basically as a result, we're not going to see any future answers that have A in it, right? We don't have to, we don't even, they're not going to be even, we don't even have to analyze the words that have A anymore. We don't have to play them anymore because we've discarded them. It's very simple to discard them, which is, we just kind of replace it. I'll show you that. Next, I'll say E, which they'll also say, well, there's a lot of words that without E, so we aren't going to do this. The third move I'll make is I'm going to guess I, which if you're using the heuristic I suggested, it will do this. I. This is because there's a lot of 8-letter words that end with ing and ion, right? A lot of them. So that is the most common word family, so that's why it reveals that, because that has the most guesses in it. It's okay with giving me a correct answer, letting me have a correct answer, because again, that just simply means that we're leading to more esoteric words if we have a bigger word list. The next guesses, though, come for free for me, which I'll guess N and G, because that gives me this. I said they have ION and ING, so by guessing N, I'm forcing the computer to choose between going ION or ING, right? By revealing, is the N here or is the N here? So the word ends with ing, right? The word will end with ing, and then from there, basically, I'll just kind of play for real to try to kind of corner the computer and to get into a word. Often the word will be something like plumbing or bluffing, right? Because next letter I'll probably guess is O, and I'll say, well, no O's, which leaves one vowel left in this 5 letters, which means that I have that it has to be U. It's kind of a strategic thing to corner these things. All right, so let's get you started on this. No, why is int?
Edge?
Yeah, you see that? I guessed int. I'm typing int, and it brings me to Microsoft Edge. How in the hell is that a best match? Go home, Microsoft. You're drunk. No, I don't want to. I like Firefox.
It's thinking of its past life as Internet Explorer.
Holy moly, you're right. That's got to be it. That's it. Yeah. It thinks I'm going for Internet Explorer, which I'm not.
Thank God, otherwise we'd be here for a while.
Oh my God. My late grandfather-in-law, he used. It was like pulling teeth to try to get him to use something other than AOL.
Oh no.
Yeah.
Are we talking about dial-up AOL? Like, for example, that's what he was still using, or we're talking about like AOL
as in the suite, the AOL suite, but like, there's a reason he got scammed out of every penny he had left. Yeah. So that was rough. All right, so let's go to Hangman. We're gonna create our new Hangman class. So we're gonna do I'm gonna outline a few functions to help you get started. The first thing we need to do is that I give you this. We're gonna go and do a very brief and hopefully very, very entertaining aside. You are all, I believe you're all adults. I didn't get any alerts that you are under the age of 18. So try to be adults about this is what I'm saying. But I do mention that I am giving you a dictionary file. This dictionary file is a spell checking dictionary, meaning it has all of the words in the English language, including the naughty ones, right? And I was asked by a student, well, can't I remove these? Can't I write a script to kind of just remove these? And the answer is no, actually. It is ridiculously difficult to remove certain words that you don't want from a file, to filter out certain language. In fact, this is a well-known problem in computer science, and we have a name for it. It's called the Scunthorpe problem. And I just want to go into a side about this as to why these words aren't here and why you might end up with a word as an answer that might be mildly embarrassing. Okay, it is the unintentional blocking of online content by a spam filter or search engine because the string or substring contains letters that are obscene or have an otherwise unacceptable meaning. The substring, for instance, there's a substring in Scunthorpe, which is quite not great language. Other examples of this are trying to register the domain name shitakemushrooms.com and not being able to do so because of the substring it contains. Another issue is that prevents a lot of issues is like if you have the name Craig Coburn, okay? It's pronounced Coburn. But even worse, this is actually something you should never do. Never ever list your job title as software specialist, because it has the substring Cialis in it, which is a very common. It's a drug that's often sent out in spam emails. That's advertised online, but it's very common in spam emails. So of course the business that you're sending it to will have a filter to prevent the accepting emails from that have that kind of substring in it.
I gotta go fix my resume.
Yep.
No, I put like a while ago. I put like technology specialist for like my Best Buy work and
Yep.
stuff, and I was like, oh, that's probably why I'm not getting calls back.
There were some other, there's a lot of other kind of email, emails that have that different substrings and stuff. But I mean, like, it is a hard problem because you'll try to come up with the perfect solution, and that your perfect solution will unintentionally block something and have knock-on effects. It is a very, very hard problem to kind of solve. And it's possibly one that you'll be asked to do. So I figure you should know about the problem because there's a non-zero chance that you will have to encounter this problem in the future. But yes, long story short, do not use the term specialist in your resumes or in your signatures for your emails, even if that's a position. They can have very hilarious consequences. I mean, mind you, you would hope that the IT person would have
Like, I don't know, something that just
an
says-
exception that captures that, yeah, but also the IT people are busy.
Yeah, trying to figure out why your monitor's not turning on.
Uh-huh. That's because it's not plugged in, of course.
Exactly.
So anyway, speaking of the dictionary file, the first thing we're going to want to do is we are going to want to load up the dictionary file. We want to read it once so that we don't have to read it multiple times, okay? We're going to read it once because we don't want to load it up a lot of times. And so we'll have this for usage later. Now, when I was talking, with maps, I've mentioned previously in the videos that they kind of have certain usages. The usages for maps are, first off, like doing key value, just general key value association, what I would like to call account retrieval or key retrieval. So for instance, product ID number, then all the stats on the product. Your email address, and then all your Amazon.com info, right? Some unique identifier. Your TUID, and then all your transcript information, right? That's kind of, here's a unique key for something, and then here is all the data for that thing. That's a very common thing for dictionaries. The other common problem we solve with dictionaries is counting, which is what you're expected to do on the exam. Here's here is a block of things I need to count. I don't know what I need to count in it. I just know I need to count how much each thing occurs. And so I will use the key to be the thing and the value to be the number of times I see that thing. Here we're going to be using this exercise focuses on that third one that we use so often, which is categorization. Now it's a bit rare, but it's a big one, and it's important to know because it really helps. And what it is that you've got a map where the key is the category, and the value is here's everything that belongs to this category. So, for instance, what we're going to do with this one is we are going to do public, and here's what we're going to return. We're going to turn a map of integer to list of string for our first one. Public, we're gonna do it static because these should be static methods. Public static integer list of strings. Read dictionary. String file name. Okay, we'll do it that simple. And what we're going to do here is that we will just simply, so let me explain what each of these are. Jeez, these allergies suck. Okay, so what we've got here is that, what are we returning? We're returning the integer is the category, and the list of strings is the thing that belong in this category. The integer is the length of the word. And the category is, here's all the words of that length. right? We could easily do like an array list where each index has a list, but I like this better because it gives you practice for future parts. This should generally be like your first thing that you try to do. I'm going to go ahead and return null so we don't have any errors. Okay. So here we read the number. We read the file. We look at a word. We ask, okay, what's its length? That gives us the key. If the key exists, then add it to the list of words that already exists. Otherwise, if the key doesn't exist, create a new list and add the word you just read to it, and then create a binding between the key and that new list. Okay. Next, what you'll probably want to do is basically a long game loop. I'll leave that up to you to figure out how you want to do with it. But the game loop basically works as follows. Okay, for the game, you're gonna, let's see, let's go ahead and public static void game. And the game will take in it will take in an initial word list. There it is, finally. I've been waiting on that one. I hate this. Okay. I don't remember allergies ever being this bad for me. Okay. List of string words. Okay. And we'll also want to pass in the other arguments you'll ask for the user. The number of guesses that they're allowed to make. The number of incorrect guesses, rather. Wow.
The floodgates are open.
What? Yeah.
Floodgates are open now.
Yeah. Okay. Public static void game, word list, number of guesses, and now what we'll do is that you'll want to use this word list to update it every so often. You'll have the number of guesses, and that will be what you need for your game loop. You'll also need this, a set of, we'll do string for simplicity. Which is the number of letters, and obviously that will initialize to null, to empty set, but that will be the set of all letters that you have guessed so far. Okay, and let's go ahead and go to the next method and see what else we need. Public static map string, comma, list. Gem word families. That'll take in string. Let's go ahead. All right, and that should be it, what we need. So what this one does is that here's our, what this one does is that it says, hey, here's the list of words we currently have. Here's our guessed, here's all the letters we've guessed. Here what we're going to do is we're going to play Hangman on each of these words to see what kind of family they end up in, what category they'll end up in. Okay, and we're going to categorize them as, hey, here's the Hangman answer for this word, here's a Hangman answer, and here's all the words that belong to that Hangman answer. Got it? So what we'll do is we'll iterate over the word list, do a for loop, and then what you have to do is you can break this out into a function, basically, and say, hey, public static string, and that, never mind. You can break it out into a function, but what you're going to do is basically say, hey, for the string, give me the combination of stuff that basically says, hey, blank blank letter blank blank, or AL blank blank blank, basically break it up. For each word, you want to generate this, okay? Which is fairly straightforward. What you do to generate that is you go through, is for every word you're looking at, you look at every letter. If it's a guessed letter, you add it to this string. If it's not a guessed letter, you add an underscore instead. Make sense? So if you've guessed the letter, you would reveal it. If you haven't guessed the letter, you don't reveal it. Yeah, I know I'm eating up a lot of time here, but I figured, yes.
What if there's multiple, how do you handle with multiple letters, multiple guessed letters appearing in a string?
Yeah, well, it's going to go through each letter one at a time. It's like it says, okay, what's the first letter? Is that an A? Have I guessed, is A guessed yet? If so, reveal it. What about L? Is that guessed yet? Yes, it is. Has I been guessed yet? No. V been guessed yet? No. E been guessed yet? No. And for all the no's, what we're doing is for every no we get, as we get a no, we add an underscore. Make sense? So that basically breaks this up into a lot of strings and a lot of, into a string and a lot of list of strings. Each of these list of strings is a potential option for the word list for the next step of the game. So rather than removing things from word list, what you're going to be doing is you're going to be taking one of these from the map. You're going to be taking one of these from the map and replacing word list in here with a new word list that you generated. That way that it keeps trimming down the words you have without ever modifying your original list of strings. Okay. Finally, what we're going to do is that we do something public static get best family, and what we'll do is we will return, and that'll be a string. And this is basically your heuristic for how you choose which one of these word lists you want, right? Because that's all we pass in as this one, okay? Word families. Make sense? So, but you use, basically what you do is you go through, you get the way the game works is that you go through, you get a guest letter from the user, okay? Then you generate word families based off of all the guesses that have been made so far, including this new one. Then you get the best family to figure out what you're trimming down your list to and what you're going to answer the user with. If the string that you get back from get best family is the same as string as the current state of the board, right? And that current state will be initialized to a bunch of blanks, right? If that string is the same as the current state, then that user made an incorrect guess because we didn't reveal anything. Make sense? So in which case we deduct a guess for them, right? Otherwise, if the state changed, we revealed if what we return from get best family is different than the current state, then we've revealed a new letter. So we don't deduct a guess for that. Okay? And then you just keep looping until they run out of guesses or they get the word. Okay. It often feels from my end that I'm like, wow, I really gave them a lot, but I know from your end that no, it's still a big mystery over here. Let's go ahead and see that before I go around this. Let's go and see this in action, how this algorithm works. But on a different game. Specifically, we're going to look at it on Absurdle. We're going to look how this algorithm works on Wordle. This is the exact same algorithm that we're using for generating correct guesses and incorrect guesses. The exact same.
The only difference is that you don't have an illustration of a dude getting hanged.
Yeah, And we're doing it with Wordle, so basically what we're doing is we're just simply where the family is slightly different. It's letter is, we add in the option of letter is also possibly not in this location. So, so for instance, if I put words here, it's going to go through and categorize every single 5-letter word it has. And it says, based off the guesses I've made, the guessed letters I've made, and where I've guessed them, where should this go, the guessed letters I've made, what would I reveal to the user? And it says the best thing to reveal that gives me the most option is to say they're all wrong and in the wrong place. Sorry, they're all wrong letters. Okay? And so, paler, pasta, right? And so here, finally, I get correct answers because words that have a U here and a Y here have the most options based off the letters I've guessed. And so we can see this by saying buggy. Actually, don't give up. And if I guess buggy now, it tells me wrong because there were plenty of more answers for it to guess, right? Like, for instance, fuzzy, right? And same thing, if I say fuzzy, unless that is the act, right? There's other words that have U blank blank, that have a blank U blank blank Y in them. So that's why, and that's also what you do when the player loses. You just choose a random word from your word list, or possibly just the first one from the word list to say, actually, this is what I was thinking of all along. You just suck at this game. Yes?
What if the first word has a letter that has the third reveal guess? So, for example,
It trims the word list as it's going, so it will not consider. It will not. It throws out all the words that would be incompatible with this future.
Basically, it's looking for a match and says,
So,
I'm not using that.
So basically, this is gonna because I guessed words first. The remaining word list is composed of words that don't have W, O, R, D, or S in it at all, because it's gone through them and said, oh, that's the best answer to give. All right, so with that, I will go around and help y'all on wherever you're stuck with in your programs.